All right, hello everyone, and welcome back to another video. We're going to be talking about area of polygons in this video. What we're going to be learning here is just how to find the area of regular polygons, and we're just going to focus on our basic shapes like triangles, squares, circles, and rectangles. By the end of this lesson, you will be able to find the area of the regular polygon with 75% accuracy, and we'll also be able to find some missing side links based on some word problems. So we're going to get right into it and discuss how to do some of these things. Here's some of the formulas that we're going to be using. Down here at the bottom, I've got a little key for what each of the letters represents. Okay, so notice that all of these are lowercase letters except for this capital C. Capital C stands for circumference, okay? Capital A is area, and sometimes right here where it has P, sometimes you'll see a capital P, that just means perimeter. But all these other ones refer to other links within our shapes. Okay, so we've talked about most of these in previous grades: triangles, rectangles, squares, and circles. The other two that you may have not talked about before are going to be the parallelograms and trapezoids. Okay, so with these, the parallelogram is very similar to the rectangle in the sense that you're just multiplying two things together. But with the parallelogram, you're taking one of the bases. It doesn't matter if it's the top base or the bottom base. You're taking one of the bases, it's the longest base, and you're multiplying it by the height of the parallelogram. Okay, so as you can see here, there may be some instances where we have to work with right triangles to figure out what the height is. But this one is just the longest base times the height. For trapezoids, this one's a little bit different because with trapezoids, we have two bases. We have a top base, we have a top base and a bottom base, and they're both different lengths. Okay, so with trapezoids, what we're doing is we're taking the two bases, base 1 and base 2, we add those two together. That's this piece of the formula inside the parentheses. Once we do that, we multiply it by the height of the trapezoid. Okay, so that the height is just going from one base to the other in a perpendicular manner. Okay, so we multiply the height with the sum of the two bases and then divide this whole thing by 2. Okay, we either divide it by 2 or multiply it by 1/2, however you want to think about it. For circles, this one's pretty straightforward. There's two different formulas that you can use to find the circumference. And we're not really going to be looking at circumference here, but just know that this C equals 2 pi r. 2 pi r is just taking the radius, multiplying it by 2. So that gives you the full diameter. And that's why we can replace this 2 pi r with pi times d, because we have 2 radii, and that is the same thing as 1 diameter. Okay, but the area for a circle is pi r squared. The one thing that's not on here is a semicircle. Okay, so I'm going to go ahead and draw this real quick. A semicircle is just half of a regular circle. Okay, so semicircle is half of a regular circle. So the area formula for this is still going to be pi r squared, but since it's half, we have to divide it by 2. Okay, if you see a quarter circle, okay, that's this right here. A quarter circle would just be pi r squared, and since it's a quarter of the circle, we would divide it by 4. Okay, so these are two other shapes that we'll be taking a look at and these are the formulas for them. Okay, so here are some examples. We're going to start off with some basic things. The first one being the square. Now, just like we've done with all of our other problems, every single time that we need to use a formula, we're going to write the formula down. Okay, so for number one, since it's a square, you can either use the formula for the square, which is s squared, s being one of the sides. I don't really like to use s. I always like to use length times width for squares and rectangles. For me, it just makes it a little bit easier. Once you have your formula written down, then it's just plugging in your numbers. So you have 8.5 for the length, 8.5 for the width. Multiply those two together, and we come up with our solution. All right, here's our solution, 72.25 feet squared. Now notice something, I didn't just write down a number, okay? Because of the fact that the square has feet attached to both of the side links, we have to multiply feet in and include the units with our final solution. Feet times feet is just feet squared. Okay. Number two is much of the same, except we're using the formula for a triangle. So there's two different ways to write the formula. You can either do 1/2 base times height, or you can do base times height divided by 2. I prefer this bottom one. That's just the way that I like to see it. For you, you may enjoy the top one a little bit better. It's just a preferential thing. Both of these will produce the same answer. Okay, so when you're looking for the base of the triangle and the height of the triangle, the height is going to go from the vertex all the way down to the base, and it makes a 90-degree angle. Okay, so this is the height of the triangle, the 21.3, and the base is 15. Okay, if they gave us, for instance, let's do this one in red. If they gave us this red height, and they said, okay, we have the red height, and then we're going to give you some number, and we're just going to call this number X for this side length. This X would be the base, and then this red dotted line would be the height. Okay, it's going to produce the same area as what we have here in blue. Okay, so it doesn't necessarily have to be the longest base, the shortest base, whatever. It's just whatever connects a vertex down to the opposite side at a 90-degree angle. That's what you're going to multiply together, the base times the height. So here we have 15 times 21.3, and we're dividing all of this by 2. And then that's going to give us an area. So this gives us an area of 319.5 meters squared. Okay, so this is about as basic as it's going to get. You don't have to find any side links. You don't have to do anything crazy. Number 3 is pretty much the same thing. It's just plugging in the links that they give to you for the formula. Okay, so the formula for this one, this is a parallelogram. So we have base times height for this one, and there's a slide at the end of this PowerPoint that has the solution for this one. Okay, number 4, this one, this is where we do have to start using some other context clues about what they gave to us to solve these area problems. But the first thing that we always do is start with our formula. So we have pi r squared, okay? This length that they gave to us, this is the diameter. So D is equal to 26 yards. The diameter is 26 yards. The radius is the diameter divided by 2, okay? Radius is the diameter divided by 2. It's half of the diameter. So to find the radius for this specific circle, I'm going to take 26 divided by 2, which gives me 13. Now I'll take my 13, plug it in for R. Area for this circle is pi times 13 squared. What you need to do before multiplying all this together is go ahead and square this number, because sometimes what you'll see with questions is they want you to leave the answer in terms of pi. So 13 squared is going to be a 169, and then pi comes at the end. So this may be one of the ways that they ask you to write the problem or write the answer to the problem. Okay, what they'll say is find the area of the circle in terms of pi, and what that means is you're leaving it like this. So you're multiplying out all the numbers, and then you're just attaching pi at the very end. Okay, if I multiply pi in to the 169, what that it ends up giving me is 530.93. And this is rounded to the 100th. And both of these need to have our units attached, which is yards squared. All right, for this one, we're going to take a look at number 5. Number 5 is a trapezoid. With trapezoids, our area is equal to the height of the trapezoid times the sum of both bases, so base 1 plus base 2, and then all of that is divided by 2. On the formula sheet, it has 1/2 times the height times the sum of the bases. I like to write it like this. It's just easier for me to see. If you use the other formula, it's going to give you the same thing. Okay, so before we start on this trapezoid, we need to identify the bases. So it doesn't matter which one you choose as base 1 or base 2, but in the trapezoid, the bases are going to be parallel. Okay, so that's something that you may want to write down. In a trapezoid, the bases are going to be parallel. All right, so here's our little note. In trapezoid, the two bases are parallel to each other. That's going to be the 19 and the 27. So when I plug them into the formula, I have to make sure that I include this parentheses here, because I have to do everything inside the parentheses before moving on to the next thing. Okay, the height connects the two bases together. That's going to be the 16. And then all of this is going to be divided by 2. All right, so for this, the first thing that I need to do is add 19 and 27 together. 9 plus 7 is a 6. 16. I carry the 1. 2 plus 2 is 4. It's 16 times 46 divided by 2. This is really doing 8 times 46. 8 times 46 gives me a solution of 368. And we're using centimeters here, 368 centimeters squared. Now for number 7, okay, this is a triangle. Okay, but what we're doing here is a little bit different because our picture looks different. So if you see a picture like this, where you have some dotted lines on the outside, okay, the point that goes from the top, or the line that goes from the top all the way down to this bottom piece at a 90-degree angle is going to be your height. So for this one, my base is the 29.5, and it's only the length that is part of the triangle. So I'm not finding where these hash marks are plus this extra piece on the green line. I'm only using the piece that is on the triangle. So you have 29.5 and I'm multiplying it by 14, and then that's being divided by 2. So 29.5 times 14. 29.5 times 14 is 413. And then I divide that by 2 to get 206.5. Include the units, it's inches squared. Right here with number 12, this is going to be our last example with a picture. And we're going to do this with a trapezoid. So with trapezoids, okay, we have the height times the sum of the two bases, base 1 plus base 2. All of that is divided by 2. Now just looking at this picture, I have two bases, the 17 or the 9 and the 19 and the 7, but I don't have a height. So I have 19 plus 7 times h divided by 2. So this puts us in a predicament. How do we find h? Well, first off, the first thing that we need to do is we need to identify where the height is. On the previous slide, we said that the height in the trapezoid connects the two bases together. Now, I need to do this in a fashion that allows me to use something else or another shape that I know to help me find this length. So remember, when we do the height, it touches the bases at a 90-degree angle. So here, I'm gonna shade this in red, kind of. It's a little bit sloppy, but this is a right triangle, okay? This shape here in red is a right triangle. So what I can do to figure out what this x is, or this h, whatever you want to label it as, is I can use the Pythagorean theorem to solve for x. Now, how do we do this in a fashion that gives me this leg? Well, it would just depend on the picture. In this case, I only have this piece that's 7. So if I break this shape down into two different parts, I've got this rectangle here, and I can take 7 away from this 19, right? Because I'm not going to use any part of this purple line where the 19 is. I'm not going to use any of this in the calculation for this red triangle. So I can do 19 minus 7, and then that's going to give me these two purple arrows. 19 minus 7 is 12. Now we're only going to be using one purple arrow. But we know that this is going to be the exact same triangle over here on the left as it is on the right because of this 10 centimeters. So what I can do is I can take this 12 and divide it by 2 to get one of the arrows, and that's going to be 6. So this arrow right here is a length of 6. I'm still solving for x, right? We're going to change it from x. I'm going to change it to h. I'm still solving for this h, okay? But to do that, we had to take away, because we have to have two numbers for this triangle. We have to have two side lengths. We have the hypotenuse, but we need another leg, so that way we can use the Pythagorean theorem to solve for h. So the way that we did that was we took this entire base, which is 19, and I just drew two lines going from this vertex where the 7 is to the 19. So we know that we can take away 7 from this whole length of 19, and that leaves us with these two arrows. And again, the reason that we divided this 12 by 2 was because we only want one arrow, and both of these legs are going to be the same length. So now that we know this is 6, I can set up the Pythagorean theorem. A squared plus b squared equals c squared. My 90-degree angle is right here. So we know that c is going to be 10. And we can choose a to be 6. So I have 6 squared plus the height squared, and that's equal to 10 squared. So we end up with h squared plus 36 equals 100. We take away 36 from both sides. H squared is equal to 64. Take the square root on both sides, and our height is going to be 8. So now I can come back over here and I can plug in 8 for h. 19 plus 7 is 26. So we have 8 times 26 divided by 2. 8 divided by 2 is 4. Then I have 4 times 26. 26 times, or 6 times 4 is 24. Carry the 2. 4 times 2 is 8 plus 2. That is 104 centimeters squared. Okay, that is the solution for number 12. In terms of problems with pictures, that's a question like number 12 is probably going to be the most difficult, just because there's so much to do. But you'll also see stuff like number 11 where you're given a picture like this, and you need to find the height before you find the area. So you would use Pythagorean theorem for number 11 to find the height, and then once you have that, then you would multiply the height times 7 and divide that by 2. Now these down here that have the directions that say use the formulas to find each measure, okay, all of these word problems, you're going to set up exactly the same as what we've been doing with the picture. So we're always going to start with the formula first. Okay, so I'll do this number 14 here with the parallelogram. This parallelogram has an area of 160.5 inches squared and a height that measures 7.5 inches. We're asked to find the length of the base. So when I set this up, I have A equals base times height. That is the formula for a parallelogram. Next up, I plug in what I know. I know that the area of this shape is 160.5 inches squared. And I know that the height is 7.5 inches. So to find B, the first thing that I need to do is get B by itself. So I divide by 7.5 on both sides. That gives me 1B. These cancel out. 160.5 divided by 7.5 is 21.4. B is 21.4. Now, what do we do with the inches? I have to cancel them. I have to cancel one of them out. So I have inches squared on the top, and I'm divided by 7.5 inches on the bottom. So this is just laws of exponents. 2 minus 1 gives me inches. So the base is 21.4 inches. All right, for our last example, we're going to take a look here at number 16. Number 16, last example. This one is talking about a trapezoid. So to begin, we are going to write down the formula for the trapezoid. And that one is the height of the trapezoid times the sum of the two bases divided by 2. Okay, now we're going to go through our question and plug in everything that we know. What they're asking us to do here is find the length of the second base. So we're looking for B2. So they should give us B1, the height and the area. And they tell us that one base measures 12 feet here. The height is 4 and the area is 58. So the way that my formula is going to look now is I'm going to have 58. The area 58 is equal to the height, which is 4, times 12, which is the first base, plus B2, and that's divided by 2. One simple thing that you can do here before you start moving stuff around is simplify what's on the right-hand side. And the way that I would simplify what's on the right-hand side is I would take a look at this 4 and 2 and I would cancel them out. 4 divided by 2 is 2. So that's going to give me 58 equals 2 times 12 plus B2. Two different ways that you could go from here. You can either take this 2 on the outside and multiply it to everything on the inside, which would be 24 plus 2B2. Or you can use some division to get rid of the 2 and divide by 2 on both sides. So that gives us a 1, and it allows us to open up the parentheses here. Then 58 divided by 2 is 19. So 19 is now equal to 12 plus base 2. To get base 2 by itself, I subtract 12 on both sides. And base 2 is equal to 7 feet. All right, so that concludes this lesson on area. Down here at the bottom, if you need some extra practice, I have some more problems for us to work on here. But at the very, very end, all of the work solutions are here for the questions that we just went through. So they have all of the same work. It may just be presented in a different way, but all of this is here for you to access. In the next video, though, we're going to be talking about composite area. Okay, so composite area is just going to be combining different shapes together and finding the total area of it. And then after that, we're going to take a look at shaded regions, which is taking a large shape and then subtracting out everything that is not shaded in. See you on the next one.